Welcome to our first lecture in the Advanced GD&T course. Today, we're starting our first section with one of the advanced topics in GD&T, and that's something called modifiers. Now, modifiers are one of those things that can seem a bit confusing at first, but once you understand them, you'll realize they're incredibly powerful. They let us describe exactly what kind of variation is acceptable on a part, not just in size, but also in how that size interacts with the part's function. Think of it this way. When we design a part, the amount of material that's present or missing can slightly change the part's behavior. Modifiers help us capture that in our drawings. So, for example, a material condition modifier tells the manufacturer or inspector, hey, when this part has the most material possible, here's how much tolerance you can allow. And when it has the least material, here's how that changes. It's all about being clear, so that what we design, what we make, and what we inspect all align perfectly. Now, according to the ASME Y 14.5 to 2018 standard, there are actually about 24 different modifiers defined. You won't use all the 24 modifier every day. In practice, most engineers and designers mostly see the common ones like MMC, maximum material condition, or LMC, least material condition, or the diameter and radius symbols, and maybe the independency symbol. These are the familiar ones you've probably already come across. But remember, there are many others out there, and each one serves a specific purpose. Some control orientation, others affect how tolerance applies under different material states, and a few are used only for specialized applications. So here's what we'll do in this section. We'll go through these modifiers one by one, see where they appear in real engineering drawings, and talk about how each one affects the part's tolerance zone. By the end of this section, my goal is for you to not just recognize these symbols, but actually understand what they mean, why they exist, and how they help ensure our parts function correctly when everything comes together in the final assembly.